Good morning. Good morning. So today class. Okay. So that today Government Polytechnic Husnabad Electrical and Electronics Engineering Digital Electronics Nedunuri Parameshwar lecturer. Okay. I have worked in Government Polytechnic Husnabad and in the Department of Electrical and Electronics Engineering. I taught a subject to digital electronics, and my name is Nirmal Parameshwar. I am working as a lecturer in electrical and electronics department. Okay. So today the objectives are. So now we are starting the fourth chapter. Today the objectives are sequential logic circuit, difference between sequential logic circuit and combinational logic circuit, and flip-flops, need for clock. So these are the objectives of today's class. So objectives are sequential logic circuit, difference between SLC and CLC. So SLC is nothing but sequential logic circuits, CLC combinational logic circuits. Okay. So for this, and next we have flip-flops, and next need for clock. Need for clock. Okay. And so today the fourth chapter, we are already completed 3 chapters, and now we are going with the fourth chapter. In third chapter we are discussing about combinational circuits. In combinational circuits we are seeing multiplexers, demultiplexers, decoders, encoders. So these topics are covered in the third chapters. In sequential circuits, let us see what we have to cover. Okay. So next first combinational circuit. In third chapter we already discussed the combinational circuit. So a logic circuit which has no memory and no feedback from output to input, and the present output depends upon the present input. So here the present input, this logic circuit is called combinational logic circuits. Okay, a logic circuits which has no memory, no feedback from output to input, and the present output depends upon the present input. So here clearly telling that in combinational circuits there is no memory and no feedback from output to input. In that, what is the present input? So this only this decides the output. So there is no need of memory and as well as feedback. Minno. So in combinational circuits, has no memory and no feedback from output to input. So the output depends upon the So this is about combinational circuit, and next we have sequential logic circuit. In sequential logic circuit, sequential logic is a type of logic circuit whose outputs depends not only on the present value of its input signals, but on the sequence of past inputs, the input history as well as. Okay, this is in contrast to combinational logic circuits. Combinational logic whose output is a function of only the present input. Okay, so sequential logic circuit is a type of logic circuit whose output depends not only on the present value of its input signals, but on the signals of past inputs, the input history as well. This is in contrast to combinational logic whose పోలేదు బాబాయ్ వస్తాడంట ఇప్పుడు ఎప్పుడు పోతావు బాబాయ్ So sequential logic is a type of logic circuit, and here clearly telling that the output of the sequential logic circuit is depends upon the input as well as past inputs. So that is nothing but in previous case what is the output is present, and what is the input, what the memory we have in previous case. So that's also is affected, that's also is that's with that feedback and memory, the memory and the output will be produced. So in combinational circuits there is no need of memory and as well as feedback, but in sequential circuit we have to consider the feedback and memory, what memory we have in past inputs and past outputs. So the sequence of past inputs and the input history as well as these are effects of depicted to the output. Okay, this is about a sequential logic circuit. So in another way, the sequential logic circuit whose outputs at any instant of time are entirely dependent upon the inputs present at that time. Its continuous consists only a part of digital system. There are many applications in which digital outputs are required to be generated in accordance with the present inputs and previous states of the circuit. These outputs to be generated that are not only depends upon the present input condition, but they also depends upon the past history of these inputs. The past history is provided by feedback from the outputs back to the input. These circuits includes the memory elements and are called as sequential circuits. Okay, so here we have sequential logic circuit examples. So examples of sequential logic circuits are flip-flops, registers, counters, clocks, etc. Computer circuits consists of combinations of logical circuits and sequential logic circuits. Combinational circuits produce outputs immediately when their input changes. Sequential circuits require clocks to control the change of state. So in addition to the combinational circuit, we require the clock input in a sequential logic circuits. So requires clocks to control the change of states. Okay. So sequential logic circuit, we are seeing the sequential logic circuit block diagram. So now see the block diagram here. So here we have combinational circuits. Already we are seeing the combinational circuit. So this combinational circuit is simply the input and we are getting output like here. So input and output. For addition to this combinational circuit, we have memory element, and this path is known as feedback path. Okay, so sequential logic circuit is nothing but combinational circuit plus memory element and feedback. So with this feedback, the input is also changes. So the changing input, the output is also changes. Okay, in a memory element we are using most probably flip-flops for storage the memory, for storing the memory. Okay, and next here we are giving the input and here getting out external inputs and external outputs. So this is the black diagram of sequential logic circuit. In this black diagram we have combinational circuit in addition to the feedback path and also memory element. Okay, so these two are the essentials for the sequential logic circuits in addition to combinational logic circuits. Okay, and next so these are the main things about sequential circuits. And digital logic circuits can be divided into two types. They are combinational logic circuits and sequential logic circuit. So already we are defined two combinational circuit as well as sequential logic circuits. Simply in a combinational circuit there is no feedback and memory element, but in a sequential circuit we have feedback and also memory element. So this is the main difference between sequential circuit and combinational circuits. In sequential circuits again we have two types. So one is sequential logic circuits and asynchronous sequential logic circuits. Okay. In sequential logic circuits we have two types: synchronous sequential circuits and asynchronous sequential logic circuit. So sequential logic circuit contains combinational logic circuit and a memory element. Memory elements are connected to the combinational circuit as a feedback path. So simply sequential logic circuit contains combinational logic circuit and a memory circuit. Memory elements are connected to the combinational circuit as a feedback path. So that is nothing but sequential logic circuit is equals to combinational circuit plus feedback plus memory element. Okay. In sequential logic circuit, present output depends upon the present inputs and also previous inputs. So examples of sequential logic circuits are serial adders, flip-flops, registers, and counters. So these are the examples of sequential logic circuits. Okay. And next we have the difference between SLC and CLC. So in short form we are writing SLC and CLC. So SLC is nothing but sequential logic circuits, CLC is nothing but combinational logic circuits. So combinational circuit is the type of circuit in which output is independent of time and only relies on the input present at the particular instant. Relies on the particular instant. On other hand, sequential circuit is the type of circuit where output not only relies on the current input but also depends on the previous output. Okay, so here clearly telling that combinational circuit is the type of circuit in which output is independent of time and only relies on input present at that particular instant. On other hand, sequential circuit is the type of circuit where output not only relies on the current input but also depends upon the previous output. Okay. And next, this is the main difference, that is black diagram. So combinational circuits we have number of inputs and number of outputs. In sequential circuits we have combinational circuits, memory element, input and output. So these are the black diagrams of combinational circuit and sequential logic circuit. And next we are discussing now difference between combinational and sequential logic circuit. So once see the CLC versus SLC. చెప్పు నాన్న చాయ్ రాలే ఎక్కడికి పోదామా ఇప్పుడే సరే పోదాంపా సో దిస్ is the block diagram of difference between block diagrams, two diagrams we have. And next, this is the comparison between combinational and sequential circuit. The first point is its outputs determined by the present values of its input only, and its outputs determined by the present values of the input as well as past values of the output. Okay, so in combinational circuits the output is depends upon present values only, but in sequential circuit the present values and as well as past values of the output. And in combinational circuit it does not have the memory. Okay, in combinational circuit అంటే ఇక్కడ మనకి మెమరీ వస్తుంది, there is no memory. In sequential circuit it has the memory and a feedback path from output to input. So in sequential circuit we have the memory and as well as a feedback path from output to input. And the third point is it does not have a feedback path from output to input. So it have no memory and also feedback. But in sequential circuit we have memory and also feedback path. Okay, and its operation can be described by the truth table. So that is the combinational circuits. We already see in the third chapter outputs, demultiplexer output, multiplexer, decoder, encoder, and every circuit output truth tables. We can determine the output by truth tables also. So its operation can be described by the truth table in combinational circuit. Its operation can be described by truth table and also time diagram. So in sequential circuit also we have truth table, and with addition to the truth table we have also timing, clock timing. So the timing diagram, its operation can be described by the truth table and timing diagram. And next, in combination circuit it have no single, it does not have a clock signal. So in combination circuits we don't have feedback, memory and also clock signal. Okay, it may or may not have clock signal, but most sequential circuits have clock signal. So in sequential circuit, some of the sequential circuits does not have the clock signal, but most of the sequential circuit have the clock signal. Okay, and next its action does not depend on clock transition. So in combinational circuits there is no clock signal, so that's why the action of the combinational circuits does not depend upon the clock signal. But its circuit is more complex than that. combinational circuits, okay, action does not depend upon the clock transition in combinational circuit, but in sequential circuits we require clock signals for the transition. Okay, so and next one is circuit is combination circuit is simpler than that of sequential logic circuit, but sequential logic circuits is complex than that of combinational circuit. Amen. So it is simpler than that of sequential logic circuit, and it's more complex than that of combinational circuit. So the combinational circuit is simpler circuit, simple one, and the sequential circuit is complex in forms. Okay, and next it built using basic gates, that is not and nor NAND nor XOR XNOR etc. Okay, the combinational circuits builds with basic gates. Okay, by using basic gates we are forming a combinational circuit. And in sequential, the sequential circuit is built with basic gates and also combinational logic circuits. So we have number of logic combinational circuits, and in addition with it logic gates also. Okay, so in sequential circuit. And next adder, subtractor, multiplexer, demultiplexer, decoder, encoder, comparator. So these are all examples for the combinational circuits. In combinational circuits we have multiplexer, demultiplexers, decoder, encoder, comparator, adder, subtractor. But in sequential circuits we have only the flip-flops, counters, shift registers. Flip-flops, counters, shift registers. Okay, so this is about comparison between combinational and sequential circuits. Okay, so difference between combinational and sequential logic circuit. So in combinational circuit present output depends only on the present input, and there are not these are not having memory elements. These are easy to design. Okay, so the combinational circuits are easy to design and operation is fast, and the examples are parallel adders, encoders, decoders, multiplexers, and demultiplexers. So this is about combinational circuits. In sequential logic circuit, present outputs depends upon the present input and also previous outputs. Present inputs and previous outputs decides the output of the sequential logic circuit, and these are having memory elements. So sequential logic circuits having memory elements and harder to design. So harder to design, and operation is also slow in process. Compared to combination circuits, the operation, so output may be taken some time to deliver output. Operation is slow. And next examples are serial order, flip flops, registers, and counters. Okay, so serial order, flip flops, registers, and counters. Next we have the topic is flip flop. So flip flop is nothing but storing element. అక్కడ శుష్క మీద ఉంది. Flip flops. A flip flop or latch is a circuit that has two stable states, can be used to store state information. A bistable multivibrator. The circuit can be made to state by signals applied to one or more control inputs and will have one or two outputs. So a flip flop or latch is a circuit. Okay, flip flop. So the another name is latch, that has two stable states and can be used to store state information. So two stable states and can be used to store state information. Okay, a bistable multivibrator. So it is also a bistable multivibrator is the one of the name of the flip flops. The circuit can be made to change by signals applied to one or more control inputs, and the circuit have one or more controlled inputs and will have one or two outputs. So one or two inputs or one or two outputs. So flip flop is a bistable device that has two stable states, that is its output either 0 volts or 5 volts, logic 0 or logic 1. So in logic 0 we are getting 0 volts, in logic 1 we are getting 5 volts. So flip flop is a bistable device. Bistable is nothing but it have two states, two stable states. So that is one is 0 volts and another one is 5 volts, and also known as logic 0, logic 1. The two stable states are generally known as set and reset. So we have two stable states now. So that are also known as set and reset. We can know that is set and reset. In set position we are get 5 volts, in reset volts we are get 0 volts. Flip flop is a memory device. Flip flop is a memory device capable of storing 1 bit information, storing 1 bit information, that is 1 either 0 or 1. Flip flop is a memory device capable of storing 1 bit information, that is 1 either 0 or 1. Flip flop is said to be in high state logic 1 or set state when Q is 1. Okay, so flip flop, okay, logic 1, high state, set state. So these three are same, but depends upon the operation we can use any one of the word. And when Q is equals to 1, then only we have high state, logic 1 state, set state. Okay, and flip flop is said to be in low state. In low state we have logic 0 state, reset state when Q is 0. So simple, In flip flop we have two states, one is 0 and another one is 1. When 0, q is 0, that is logic 0 and in reset position and low state, and q is 1, that is a high state. In this set state logic 1 position. Okay, and next flip flops is a storage device which stores 1 when output q1 q equals to 1 and stores 0 when q is 0. So output when q equals to 1, then it stores 1. When q equals to 0, then it stores 0. Okay, so that's why it's called flip flop is a storage device. Flip flops are the fundamental components of shift registers and counters. So flip flops are the fundamental components of shift registers and counters. Okay, a flip flop is an electronic circuit with two stable states that can be stored binary data. The stored data can be changed by applying varying inputs. Flip flop and latches are fundamental building blocks of digital electronics system used in computers, communications, and many other types of systems. Flip flops and latches are used as data storage elements. It is the basic storage elements. It is the basic storage elements in sequential logic. But first, let's clarify the difference between latch and flip flop. Because these are the types of flip flops we have. So we have SR flip flop, that is set reset type. Okay, and next D type flip flop, and next JK flip flop, T flip flop, and also we have one more flip flop, that is master slave flip flop. So first one is SR flip flop. S means set, R means reset. So basic data storage device which holds the data until reset occurs. So it stores the data until the reset occurs. So yes, the flip flops. Basic data storage device which holds data until reset occurs. Okay, JK flip flops. Most versatile of basic flip flop, two input behaviors plus toggle type behavior. So in JK flip flop we have extra, that is toggle type behavior in addition to the SR. Okay, so D type is we have only one input and two outputs. Basic data flip flop has advantages of simpler wiring than JK version. So the advanced version of JK type flip flop is D type. Okay, so toggle action is used for counters in toggle type flip flop. Can be constructed from any of the basic flip flops. Okay, so all types of flip flops can be constructed by toggle flip flop. Okay, so these are the types of flip flops we have: SR type flip flops, SR flip flops, JK flip flop, D type flip flop, toggle flip flop, and master slave flip flop also. Okay. So in next class, need for class, so they have to Thank you. Okay. Thank you. Stay safe. Stay home.